And now we go for part C of question 1 in the third midterm for 5 marks. Given the magnitude characteristic shown below, this one, find h of s, the corresponding transfer function, and also the value of a, this peak in decibels, a. Same as before the exam, assume that there are no poles and no zeros on the right-hand side of the complex plane, and there are no quadratic terms either. And also, the constant term is non-negative. These are simplifying assumptions. We see that the curve enters from the left with a positive slope of 20 decibels per decade. That is a clear indication that there is a simple zero at 0. And we write it down. And then at 7, the slope changes from plus 20 decibels per decade to 0. That is a clear indication that 7 is a simple pole. And we write it down here. And it continues that at 70, the slope changes from 0 to plus 20, so 70 constitutes a simple 0. And we write it up here. And finally, at 500, the slope changes from plus 20 decibels per decade to negative 20 decibels per decade. That is a dive of negative 40 decibels per decade. So 500 is a double pole. Why a double pole and not a pair of complex conjugate with an undamped frequency of 500? Because the problem says there are no quadratic terms. So that is the shape of the transfer function we're looking for. But we still need to find k, and with k we can find what is the value of a. What piece of data we have for that? This one. That approximated plot has a value of 10 decibels at 7 radians per second. But what is the value of that approximation at 7 decibels? You say, if there was no 0 at 0 at 7. But we have to add the contribution of the 0 at 0. What is this? Well, check this out. The 0 at 0 at the frequency 1 has no contribution whatsoever, but at 7 is these many decades above 1 radians per second multiplied by the slope 20. This is the contribution of the 0 at 0, and that is equal to 10 decibels. And from there, we can find the value of the constant k. That is the value of that constant, 11,293.8. So we're good. We have found what is the value of k. What about the value of a? Well, the value of a is 10 decibels plus this rise from 10 all the way to the top. But this slope is 20 decibels per decade, and we know the distance between 70 and 500. That is log 10 of 500 over 70. Those are decades. Multiply that times 20, and you get that the value of a is 10 decibels plus 20 logarithm of 500 over 70, right? Number of decades times slope, and that is 27 decibels. And let me have a peek. 0.077. 0.77 decibels. And that is the solution to this question.